name is John, and our project will be about DC motors. A DC motor stands for a direct current motor. There are motors used in many things like toys, appliances, and tools. One important use for a DC motor would be that they are used for powering electricity in cities. One city in particular that uses a DC motor for electricity is San Francisco. DC motors are also important because they are used for more industrial tools in factories because of their ability to stop, accelerate, and reverse quickly. For example, in conveyor belts and turntables.
Here is our DC motor. It's a simple electric motor, but it fully demonstrates how the motor works. You can find a DIY kit on Amazon for just $13.99 and assemble it yourself. It comes with an English manual, so it's easy to assemble and disassemble.
The DC motor is made of many components. The first part is the plastic base, which holds everything together. Second is the permanent magnet. The third part includes the brass brushes. Fourth is the commutator, and the fifth is the armature, which is the structure that has the copper coiled around it. Now, the commutator and the armature will be spinning at the same time together. The sixth part includes the wires and cords, which are connected to the 9-volt battery, which will be the energy source for the motor.
You can see we've assembled our DC motor. We connected our cords to our battery. We opted to tape it to the battery just for safety precautions. And now I'll show you how it works. The reason why our motor functions like this is due to two laws: Faraday's law of induction and Fleming's right-hand rule. Faraday's law of induction states that the circuit with a current in it, which is our armature in this case, repels the magnetic field that is created by the permanent magnet and creates a torque that will drive the motor to continue rotating. But Fleming's right-hand rule also states that whenever the ring is at a 90-degree angle position with the magnetic field, it will change the direction of its current, which will give us an alternating current instead of a direct current. The reason we have a direct current is due to our commutator. This structure spins at the same time and direction as the armature, which changes the contact for every halfway rotation and makes sure that this current does not change direction, giving us a direct current motor. I also have some diagrams to better explain how a DC motor works, but before I get into them, I need to explain a couple of concepts. The magnetic field of our permanent magnet is moving from the North Pole to the South Pole. But we also need to keep in mind that the coil in our DC motor also acts as a magnet. And when a magnet is within a magnetic field, it will try to align with it, meaning that it'll move in the direction of the pole that corresponds to it. As you can see, here are some diagrams that represent the movement of the coil due to the influence of the current and magnetic field. Now, the north pole of our coil is facing the north pole of the magnet, and this is represented by number 1. This creates repulsion, so number 1 will try to move to the other side. But what we notice in stage 4 to 5 is that the commutator will change the direction of number 1. The commutator will do this because it wants to maintain a current of the same direction, or a direct current. This is why our motor is a direct current motor instead of an alternating current motor. Now, it is also important to note that this movement creates two forces, one being on the North Pole and one on the South Pole. These forces are of opposing directions and they have a distance between them. This is a simple example of a torque, which is what will keep our motor rotating.